Hey everybody, this is a quick little video over our intensive versus extensive properties PowerPoint. There's only 8 slides, so hopefully it won't take us a real long time to get this conversation taken care of. This tends to be a little bit of a problem area for you guys because you've never talked about extensive and intensive properties before, and it's just kind of it's not really a gray area, but for some reason it still is a little bit difficult. So let's get started. All right, let's use the basic definitions that we had from our properties of matter PowerPoint. Extensive properties, those that matter or they depend on how much is there, how much material is there. They're additive. If I add more, I get more of this particular property or property changes. If I have less, the property changes. The opposite of that would be intensive properties. These are characteristics of matter that have nothing to do with how much material is there. It's not additive. I can double it, I can quadruple it, I can take it times 100,000, and it's still going to be the same property. All right, so you're going to find, if you go online, lots of little lists that have intensive and extensive properties, and they're going to have little pictures and all that great wonderful stuff, but the lists don't help you if you don't really understand why a property is intensive or extensive. In fact, let me just show you these couple of lists. You can see that we're looking at intensive properties first. Intensive properties are broken into physical properties and chemical properties. Physical properties are the things that you and I would just spend our time talking about. It's green, it's going to boil at 100 degrees, it's shiny, it's lustrous, it's pretty dense, it's kind of heavy, it's a round object. And various other things. One of the ones we're going to talk about in a little while is something called specific heat capacity. So I'm going to kind of hang that one out there for a little bit. But these are all physical properties that do not depend on how much material is there. If it's red, it's red. It doesn't matter if it's 1 gram of something or 40. All right, then the other one is intensive chemical properties. These are all, in fact, let me stop for a second. All chemical properties are intensive. All chemical properties are considered to be intensive. Why? Because if something's going to burn in the air, it doesn't matter how much is there. It really doesn't matter. It's going to burn. If something's going to rust, it doesn't matter if it's 1 stick of iron or 3. It doesn't matter how much is there. And that's what the intensive means. It does not matter how much of it we have. All right, let's look at extensive properties. These, on the other hand, are the ones that do matter. If you add more mass, generally the volume goes up. Lots of times it's going to be a longer object. If you have more electrons moving, down at the bottom you can see you have what's called an electrical current. If you have fewer electrons moving, you have a smaller electron current, or electrical current. So you have to understand it matters how much is there. The bathtub and the glass of water deals with this thing called heat capacity. And again, we're going to have that conversation in a little while. But these are all things that say if there's more of it, it matters. So what I want to do is I just want to look at 2 pieces of sulfur first. Just very simple. And I want you to look at the data at the top. This is extensive data. Grams and volume. The sulfur crystals on the left are yellow. They have a melting point of 115, which are the data points from the bottom box. You know what? It doesn't matter. I can add another sulfur crystal just like the one that's there. And it'll still be yellow and it'll still be 115.2 degrees melting point. But what will have changed is now I will end up with 78 grams. And I will end up with a volume that is probably closer to 37.6 centimeters cubed. All right, let's look on the other side. I've got sulfur powder. So what's the difference between the two of them? Well, one's a powder, the other's a crystal. That's a physical property, but it's an intensive property. It doesn't matter how much of the sulfur powder I have. It's still going to be a powder. It's still going to be yellow. But if I cut it in half, instead of having 0.84 grams, I have 0.42. I have less mass because I took mass away. It's additive. and the mass and volume changes. All right, so what I want to do is kind of slow down and let you do this with me with this beaker of water. And right now all I want you to do is just talk about the properties of the water in the beaker that's been sitting out in the room. Now it's been there since this morning. I would love for you to pause the video and talk to somebody you're sitting next to. If you're virtual, find a way of being able to chat with each other and talk about the properties of the water in the beaker that's been sitting out all day. All right? So I'm going to stop and you're going to come back to me. Okay, so welcome back. So here are some of the traits that I thought about when we were doing this. All right, so we have, it's a clear liquid. It's at room temperature. I said it's been out all day. The volume is 80 milliliters. We're saying each one of those lines in the beaker is worth 10 milliliters. Obviously, it's water. We know that water freezes at 0 degrees Celsius. It boils at 100 degrees Celsius. You may not know this, but the density of water is 1.0 grams per milliliter, which means the mass is 80 grams. Right? Those are all properties of that beaker of water. So what I'd like to do is this. I would like to ask you to replace it with a different beaker. All right? It's still been sitting out in the room since this morning. And what I'd like for you to do is go to each one of these properties you just got finished talking about and see if they stayed the same. If they stay the same, even though we have less water, we are talking about an intensive property. So, is it still a clear liquid? Yep, it is. Is it still at room temperature? It's been sitting out since this morning, so yes, it is. Is the volume still at 80 milliliters? No, it's at 1 and almost 2. It's closer to 20 milliliters. Is it still water? Sure is. Does it still, even though there's less of it, freeze at 0 and boil at 100? Yes, it does. Is the density, even though there's less of it, still 1.0 grams? Yes. But is the mass still 80? And the answer is no. So volume and mass are the only two things that don't have the smiley face. Those are the only two extensive properties of water and the ones that we identified. All right. So the last example here, this is the last slide, is let's heat the water. We're going to heat the water in the two containers and we're going to do it to boiling. And remember, we said it doesn't matter how much water, it's going to boil at 100 degrees. The water in the tub, just because it's more, doesn't boil at a higher temperature. But it's going to take a longer time to boil it, isn't it? Why? Which one requires more energy to heat the water to boiling? The tub. Why? Because there's more water there. That's referred to as a heat capacity. It's going to take more energy to heat the water in the tub to boiling than a small container. Now, if you were to take drop by drop, a drop of water in, or let's go with a gram of water from the cup and a gram of water from the tub, they're going to take the same amount of energy, but that's on a gram basis. That's called specific heat capacity. And the value is one that we're going to talk about many times over the year. It's 4.186 joules per gram per degree. So if I have a gram of water, it's going to take 4.186 joules of energy to raise it 1 degree Celsius. But guys, if I have 50 grams, it's going to take me 50 times that much. If I have 100 grams, it's going to take me 100 times that much. That's the heat capacity of the container of water. Not of water, but the container of water. So what I want you to say is this, and again, we're going back to the thing. It says the boiling temperature of water is intensive. Why? Because it doesn't change depending on how much is there. However, the amount of energy needed to get to the boiling temperature is extensive. It takes more to get the tub to boiling than it does the cup. All right, so guys, that's my quick thing about intensive and extensive properties. Part of the lab you're going to be doing is you're going to be doing some stuff. This is why I needed everybody to have pennies today that is going to be dealing with intensive and extensive properties of matter. So let's take care of the other video and then let's get ready for the lab.